Hey everyone, this mini lecture covers what's called the midsegment of a triangle. So first let's take a look at the triangle midsegment theorem. So we have triangle ACB or ABC, CAB, whatever you like to call it, that's fine. But we have a triangle. And within the triangle, we have a line segment DE that goes across. And also the base of the triangle is line segment AB. So the triangle midsegment theorem tells us this. It tells us that if D is a midpoint, if that point D is a midpoint, and if it's a midpoint of what? Well, if it's a midpoint of that side AC, or that line segment AC, and also if E is a midpoint of what? Well, if it's a midpoint of that side CB, then that gives us some information. That tells us that that segment DE is parallel to that segment AB. So if D is the midpoint of AC and E is the midpoint of this CB, then that tells us that that line segment DE is also parallel to the line segment AB on that triangle. It tells us a bit more information as well. So I'll say and. It also tells us that DE is equal to 1/2 times AB. DE is equal to 1/2 of AB. So this line segment DE is calculated by calculating 1/2 of this line segment's length AB. So in our first example, we have triangle LMN. In triangle LMN, we have LE being congruent to EM. We also have MF being congruent to FN. So this tells us that point E must be the midpoint of LM, and point F must be the midpoint of MN. If that's the case, then EF, that segment going across in the middle of that triangle, is parallel to LN. Also, we know from the midsegment theorem that EF is about 1/2 of LN. So when looking at these problems, looking at the picture is one thing, but understand that they're usually not drawn to scale. So we have to actually apply the theorems, and if the parts of the theorems are true, then we can actually go ahead and use them and work through them. All right, so we're gonna find LN. That's what's wanted in this problem. So we're gonna say, by using that theorem, that EF is 1/2 of LN. Right? So I'll write that out. EF is 1/2 of LN. Well, what is EF? EF is labeled as x plus 2. So x plus 2 is 1/2 of LN. And LN is x plus 10. X plus 10. Okay. So now we have an algebra problem that we can solve. We're gonna go ahead and take care of these parentheses, right? And then distribute through. So we have x plus 2 equals 1/2 times x and times 10. 1/2 times x is 1/2 x. 1/2 times 10 is just saying what's half of 10? Well, 1/2 times 10, or half of 10, is 5. All right, now we're solving for x, so we want to get the x's on one side, the numbers on the other side. So I'm going to go ahead and subtract 1/2 x from both sides, right? Because what I do to one side, I have to do to the other. So I have 1x over here minus 1/2 of x. That leaves another 1/2 x plus the 2 equals 5. So now I'm almost there. I have the x's on one side. I need the constants on the other, so I'll subtract 2 from both sides. So then I have 1/2 x equals 3. All right, so 1/2 x equals 3. So 1/2 x equals 3. The next thing I'm going to do is divide both sides by 1/2. Right? You can even make it simpler if you don't want to deal with the fractions. You know that 1/2 is the same as 0.5, so we can say 0.5x equals 3. If you didn't know that, you can just type in your calculator 1 divided by 2 and it'll get you 0.5. Alright, but either way, we have 0.5x equals 3. Now to get x by itself, we look next to the x and see the 0.5 and we divide by it, because between 0.5 and x is multiplication. So I'm going to divide by 0.5. What I do to one side, I must do to the other. Divide that side by 1/2 as well. So then 0.5's cancel and we're left with x equals 3 divided by 1/2, or 3 divided by 0.5, which gets us 6. Now you've solved the algebra portion of the problem, but that doesn't always mean you've solved the actual problem in its entirety, right? Because it's said to find ln. Well, ln is x plus 10. So you need to just plug in for x. So we found x to be 6. So we plug in 6 for x. So then we get 16. So ln is equal to 16, whatever units they're using. Our next example shows us the triangle UST. Triangle UST. So it's oriented a bit different from the last one, but still pretty similar. It shows us that line segment ST has two congruent pieces in SR and RT. It's telling us that they're congruent from this tick mark. It's also telling us that segment UT has two congruent pieces, which are UQ and QT. It's telling us this by these two hash marks. Therefore, we know that R is a midpoint and Q is a midpoint. Thus, QR is the midsegment of this triangle, and it's parallel to US. Also, we can say from the midsegment theorem that x minus t, this segment QR, is about 1/2 of US, the x plus 3. So QR, or RQ, whatever you want to call it, we just said that it's 1/2 of US according to the midsegment theorem. Well, let's just plug in what they gave us. RQ is x minus 2. 1/2 of US. US is the x plus 3. And now we have an algebraic equation where we're just going to go ahead and solve for x. I'm going to just jump right into it and change my 1/2 to 0.5 right away. You can keep the fraction if you choose, if you want to work with it, or just change it to a decimal. So I have 0.5 times the quantity of x plus 3. The first thing I know I need to do is go ahead and distribute the 0.5. So we have x minus 2 equals 0.5x. 0.5 times 3 gets me about 1.5. The next thing I want to do is get the x's to the left and the numbers to the right. So I'm going to subtract 0.5x, subtract 0.5x. So you know and I know that x really has an invisible 1 in front of it. So it's really 1x. 1x minus 0.5x. So you have one whole, you're taking away a half. that leaves you with the other half. And then we bring down the -2, bring down the equal sign, bring down the 1.5. All right, we're almost there. We need to move the constants over to the right. So I'm going to add 2 to both sides. Remember, when adding decimals, whole numbers get lined up. All the other place values get lined up as well. So you have 0.5x is equal to 3.5. The last thing we want to do is get x by itself. So between 0.5 and x's multiplication, we do the opposite, division. So what you do to one side, you divide. So you do the same thing to the other side. So x is equal to dividing 3.5 by 0.5. So 3.5 by a half. So x is equal to 7. All right. So the problem said to find RQ. Right? It said find RQ. So we don't stop there. And you know and I know RQ is x minus 2 because that's what they told us in the diagram. So all we do is substitute in for x. So we get 7 minus 2 and we get 5. So RQ is 5 units.